Hello art students, this video is about reading a ruler and measuring. And some of you may not need this review. Some of you may feel like you've kind of mastered that. And that's fantastic, but a lot of my art haven't. And I think sometimes our math teachers know math, so they have a hard time teaching it to people who just don't get math. So I teach when we discuss reading a ruler, because that's how we read a ruler. We use fractions, but I teach it from the perspective of someone who is visual, somebody who's into art, who often struggles with some of those math concepts that are numerical based. So to begin with, we're going to look at simple fractions, because again, I think this is where a lot of students feel lost when it comes to reading a ruler. So when we have fractions, essentially what we're saying is that we have this, in this instance, that whole thing is just a circle. The fraction means that it's divided into smaller parts. However, it's divided in is your denominator. However many parts you want to keep or you're going to do something with is your numerator. So for instance, in this first circle, our whole is divided with one line, meaning there's 1/2 on the left, 1/2 on the right. So our denominator is 2. The directions say write the fraction of the shape that is filled in. So we have a denominator of 2 because there's 2 halves, and our numerator has already been filled in because they're kind of giving us a little help. So we've got 1 is shaded. So 1 of the 2 halves is shaded. 1/2, 1/2. When we move over here to the one to the right of that, our entire whole circle is divided into 4 sections. So our denominator, our bottom number, is 4. How many of those sections are shaded in? Only 1 of the 4. So that becomes our numerator. So again, we had 4 possible sections, but only 1 is colored in. When we look at, let's skip ahead to one that's a little bit harder. This guy has 1, 2, 3, 4, 5, 6, 7, 8 sections, which means there's 8 possible parts out of that whole. Only 1 is shaded in. So our numerator is 1. To the right of that, we have the whole circle. It's divided into 1, 2, 3, 4 parts. Our denominator is 4. 3 of those parts are shaded in, 1, 2, 3. So our numerator is 3. So those are some pretty simple fractions, and you might be thinking, yep, I've got that. But maybe when it comes to the reducing the fractions to their simplest form is what gets you. We're going to move on to that. But for now, I just want to make sure we're all on the same playing field. Your denominator means how many parts there were to make the whole. Your numerator is how many of them that you're using for something. Those are your notes, numerator and denominator. So when we look at a ruler, generally a ruler is marked in 1/16 of an inch. So that means all of our fractions are going to be over 16. So you'll some number over 16. The way you can tell how many fractions are within your inch is to count how many sections divide it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. After a while, you can look at a ruler and just tell whether it has 16 sections, but some rulers don't. I've got an example here. I'm not sure if I can get that to focus or not. But if you can tell, the very first section of this ruler is actually divided into 32nds of an inch rather than 16ths. Some rulers are divided into 4ths, some rulers are only divided in half, and some rulers just have whole inches and no divisions in between. So it's important to kind of make sure that you are using a 1/16 of an inch ruler. And the reason we use 1/16 as kind of a measurement is because that's what most rulers are. 1/16 of an inch is typically small enough that you get enough detail without being over exact. So for most things in art, 1/16 of an inch is close enough. So again, we're looking at an inch that's divided into 16 sections. So we have this one whole inch divided into 16 parts. This very first mark means 0. You don't have any parts of that inch. So your fraction would be 0/16, nothing. If we look at the first space, when we get to that first tick mark, we're going to write 1/16 because we have one section out of the whole possible 16 sections. If we go to the second mark, 1, 2, we have 2/16. So here's the rule with reducing your fractions. If you have an odd number over an even number, it does not need to be reduced. It is already in its simplest form. So odd number, that's 1, 3, 5, etc. Over even number, 2, 4, 6, 8, etc. This is already reduced. But when you have an even number over another even number, for instance 2/16, it is not at its simplest form. The easiest way, if you're not so good at remembering your multiplication and division, to figure out how to reduce that fraction is to just always divide both the numerator and the denominator by 2. So if I have 2/16, which we call 16ths, and I divide by 2 across the top, that makes 1. Divide by 2 across the bottom, that makes 8. That means that 2/16 is the same thing as 1/8. This is just a smaller, reduced version of the same exact number. If we were to use our little pie charts and divide this section so that instead of having 2 on the bottom, we would have 4. Instead of having 1 on the top, we would have 2. So when you divide by 2, you get 1. When you divide by 2, you get 2. It's the exact same number. This is just not a reduced version of that number. So if we kept going, 1, 2, 3 sections. 3/16. Something I see a lot of students do that is completely incorrect is want to write decimals instead of fractions. They look nice and neat and clean, and that's fine, but decimals mean that you're working in tenths. So if you have an inch that's divided in 10, you can use a decimal point and that's accurate. But if you say 0 inches and 3.3, it's not the exact same thing as saying 0 inches and 3/16. Again, decimals means it's divided into 10, always. One section, 2, 3, 4. 4/16. That's an even number over an even number, so we can reduce that. 4/16 divided by 2 equals 2/8. We still have an even number, so we're going to divide by 2 again. Whatever you do to the top, you do to the bottom. 2 divided by 2 is 1. 8 divided by 2 is 4. So 4/16 is the same thing as 1/4. I'm going to keep going down the ruler. Feel free to skip ahead if you feel like you've got this part, but I want to make sure that everybody understands what each of these marks mean. 1, 2, 3, 4, 5 sections. 5/16. Odd number over even, we're already reduced. 1, 2, 3, 4, 5, 6 sections. 6/16. So we've got to do some reducing. 6/16 divided by 2 equals 3/8. So this is the same. 6 over 16 is the same as 3/8. 1, 2, 3, 4, 5, 6, 7 over 16. 8 over 16. 8 goes into 16 one time, so it's the exact same thing as 1 half. 9, 10, 11, 12, 13, 14, 15, 16. Each of those sections just means you've moved one section more out of the 16. So that would be 9 over 16, 10 over 16. We're marking the end of the section where the mark indicates that it ends. 11 over 16, 12 over 16, 13 over 16, 14 over 16, 15 over 16, and 16 over 16. Anytime you have the same number on the top and the bottom, the numerator and the denominator match, that means you have all of the parts that make a whole, which is equal to one whole. That's where that 1 comes from. Looking back at all of our numbers that have even over even, we can reduce those. So 10 over 16 divided by 2 on the top, that makes 5. 16 divided by 2 is 8. So 10/16 is the same as 5/8. 11 over 16 is odd over even. We're good. 12 over 16 is even over odd. So let's do some reducing. Divide the top by 2, 6. The bottom by 2, 8. We still have even over even. So we're going to reduce that again, or divide again. 6 divided by 2 is 3. 8 divided by 2 is 4. That is as low as it'll go. It is totally reduced. 3/4 is the same thing as 6/8, which is the same thing as 12/16. 13 over 16 is odd over even, so it's already reduced. 14 over 16 is 2 even numbers, so dividing by 2. 14 is divided by 2 7 times. 16 is divided by 2 8 times. So 14/16 is the same as 7/8. 15 over 16 is odd over even. So again, we're good. We don't have to reduce that one. See me if this is still confusing. Again, just follow the rules. An even number over an odd number over an even number means that you don't have to reduce. But if you have an even number over an even number, divide by 2 until you end up with an odd number over an even number. Moving on to actually using our ruler to measure. We're going to start with just this paper copy, and this isn't the one that I thought I had, which kind of stinks, but we'll make it do. So I'm just going to draw a random line so we can figure out how long that line is. Sorry, I'm sure my desk noises are crazy loud. Starting right on the 0, random line, random line. Let's make a little line, and then we'll just do a few of these. All right, so looking at our first inch, the first thing we want to remember is that we always have to count how many whole inches there already are before we start looking at fractions of an inch. In this one, we have 1, 2, 3, 4, and I feel like that line comes pretty much right up to the edge of the 5-inch mark. So this one's kind of easy. Luck of the draw, huh? So what I'm going to do is I'm going to write 5 whole inches. There is no fraction to follow because it ends at the 5-inch mark. The symbol for inches, take note of this, is 2 little quotation marks, little dashes that go just past your number. That symbolizes inches, so you don't have to write the word inches out every single time. If it were just one little dash, it would be feet. But when you have inches, you use the 2 dashes together. On our next mark, notice that our ruler doesn't start on 1. I was just creating a sheet that had different examples for you. 7, 8, 9. We don't quite make it all the way to 10. We end right about there, right in front of the 10. So we've got 9 whole inches that are complete. How many sections after the 9 do we have over the 16? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 over 16. That means out of the 16 places that make up that last whole inch, we keep 15 of them, and the 16th one is empty. For our next measurement, we have 1 whole inch, 2 whole inches. We don't quite make it to 3. 2. Let's look at our fraction. Starting from the, how many spaces do we use before we get to the 3? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 over 16 inches. On our next measurement, we have 7 whole inches. We don't make it to the 8. 7. How many spaces between the 7 and the 8 do we see? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I would state that's closer to 11 than 12. So we're going to go with 11 over 16. And this is why you would use 32nds of an inch rather than 16ths, because 32nds of an inch is going to give you a tiny little mark in between each of these guys, so you can be more exact. But again, for the sake of what we do in art class, 16ths, pretty close. And here we have just this little. First of all, when you are measuring something, make sure to always start at the 0 mark. You don't want anything hanging over that edge, because that's going to throw off the length of your object that you're measuring. So we have 0 inches. We don't make it to the 1. You don't have to write 0, but for the sake of making sure we all understand, we'll just put a little light 0 in there. How many sections between that 0 and 1 out of the possible 16 are we using? 1, 2, 3, and I think we're a little bit closer to the 4 on this one. So 4 over 16. Notice we've got an even number over an even number though, so we can do some reducing. 4 over 16 divided by 2. Whatever you do to the top, you do to the bottom. 4 divided by 2 is 2. 16 divided by 2 is 8. We still have an even number over an even number, so we're going to divide by 2 again. 2 divided by 2 is 1. 8 divided by 2 is 4. So this is 1/4 of an inch. So far, so good. Let's look at measuring an actual object so that you can get a feel for how that would be done. Oh, my ruler's a little shiny. I hope you can see it. So again, this ruler has 32nds of an inch here at the beginning. You would just want to keep that in mind if you're measuring something that was smaller than 1 whole inch. We're not, so we're just going to go with it. Some rulers start with the 0 right along the edge. So you want to pay attention to whether or not there's a space. A little bit high rulers tend to start just a little bit over the edge so that as the ruler gets worn down, you still have an accurate measurement. So this one starts just past that edge. So I've got my end of my pen lined up with the 0. I'm going to count my whole inches. 1, 2, 3, 4, 5, but we don't quite make it to 6, so our whole inches are 5. How many sections between 5 and 6 do we have out of the possible 16? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 out of 16 inches. So that has an even number over an even number, which means we can reduce it. 14 divided by 2 is going to be 7. 16 divided by 2 is 8. So our ink pen is 5 7/8 inches long. Please let me know if you still have some confusion about any of this. Fractions can be tricky, but like I said, I do feel like teaching them from the visual perspective makes them a little more easy to understand. So remember your key terms that we use 1/16 of an inch. The denominator tells you how many possible parts there are in the whole, while the numerator tells you how many you're using. And you have your little quotation tick marks that symbolize inches. Thank you, and I hope you have a great day.